everyone. Dear participants, I would like to welcome you on behalf of our university. I'm really glad to see you all here. Before starting our session, I would like to give you brief information about our university because some of you may not know about it. Mardin Artuklu University was established in 2007. Mardin is an ancient city known for its historical and cultural wealth. People of different languages, different races, and different cultures live together in Mardin. As a university, our mission is to raise exemplary individuals who have adopted an innovative and critical view based on local and universal value. As a university, we try to make sure that our students are equipped with moral values, care about the environment, have professional responsibility, and contribute to the heritage of humanity, and to become a leading university conducting original researches in this field. Today, we're going to talk about renewable energy sources. Well, what we generally know actually that energy consumption is a huge part of our daily life. We live with energy, we travel with energy, we work with energy, and we even float with energy. But where does all this energy come from? We generally know that today we get most of our energy from coal, oil, and natural gas, also known as fossil fuels. We obtain energy from different sources, renewable sources and non-renewable sources. Renewable energy sources refer to all these limitless sources present in the nature: the sun, the wind, the force of water, and the inner heat of the earth are examples of these renewable energy sources. But I'm sure I'm going to present our participants, and I know you all have remarkable experience and knowledge about this. If you let me, I will just ask Dan to start as a first participant and to tell us all about renewable energy and all about solar energy. And please, let's listen to him. Go ahead, Dan.
My thanks. So we'll do all that in 10 minutes, right?
Yeah.
So I will share my screen and I'll describe, of course, what I'm saying for anyone who cannot see who is not being able to join with video. So first of all, my thanks for having me on with you. It's really a critical moment to think about, not only about the science and technology of clean energy. I myself am a physicist and started much of my work on the material science side of solar and of batteries. But I find myself increasingly looking at energy systems. And I do that both in my job at the university here in California, but also in some positions I've held for the United States government, when science is the language, but really negotiations and partnership are really the goal. And so what I'll try to highlight in my brief comments today are really some of the opportunities where we can accelerate the science and we can accelerate the path of decarbonization to cleaner energy, but doing so that we promote social justice. And I think that for us, that's one of the most important new innovations. More important, I think, than thinking about new solar cells or new wind turbines or other technologies. It's really the opportunity to build a healthier political as well as climate system by looking at this through justice. And so if any of the comments I have, you'd like to have copies, my laboratory website is called the Renewable and Appropriate Energy Lab, rail.berkeley.edu. And then for those of you who use Twitter, although this seems like a we join in group, but if you use Twitter, we try to tweet about once a day here. So what I really want to highlight is something that everyone on this panel will be very familiar with, and that's the story that we told going into the Paris Climate Conference in 2015, where we know we needed to move off of the red path. We needed to move to a lower carbon economy. The negotiations were complicated, but the agreements were that we would cut emissions by roughly 1 degree. If every country did what they said, we would, we believe, cut emissions from about 4.5 degrees Celsius path to 3.5. That's not sufficient, but that's what countries agreed to. As of today, only 2 countries, not my country, not Germany, not Denmark, are on path. The only 2 countries certified to be on their path for this pathway are in Africa. They're Morocco and the Gambia. And that probably surprises some people, but they've committed much more seriously than many others. Now, when we look at this pathway, what we committed to, but we're not on pace to do, are the red. What we need to do in the future are new innovations. So we need a mixture of rapid deployment of what we can do and continuing innovation. And in fact, the Paris meeting was so exciting, and maybe there was so much good wine, that 6 months later, all the countries committed to another half degree in the Kigali Accords. On the United States, we signed this with our Secretary of State, John Kerry, who I worked for in the State Department at the time. But of course, back then, our path was to keep the world under 2 degrees. Now, the IPCC, which I'm a part, has set a new target of 1.5. And since we've already warmed the planet by 1.2, we have barely any headroom left. So that's why I say both the investment in innovation, but the pace of accelerating change are critical. Here in California, we have a path. These are our emissions history from different sectors, but we are on a path to become carbon neutral by 2045. California is the 5th largest economy on the planet, and our decarbonization will be a mixture of solar, wind, geothermal, and energy efficiency. We do not include nuclear in that mix. And as a professor of nuclear engineering, we may come back to that topic later on. It's a complicated one for me. But our path is to be carbon neutral before mid-century. But in the last few months, we've seen a number of new innovations to accelerate this. California will now end the sale of internal combustion vehicles by 2035. And with the recent announcements by the United Kingdom and the United States state of Massachusetts saying they will end sales of internal combustion vehicles by 2030, my guess is California will try to leapfrog ahead and maybe pick 2030 or earlier. But this shows how investing in one area, cleaner vehicles, can open up markets for clean energy, can accelerate a process. In fact, in California, we are now discussing a new target of becoming carbon neutral as early as 2035. Currently, the goal is 2045, but 2035 is under discussion, and I'll explain why in the next few moments. The reason we can be confident is that California's initial plan was to get 20% of our power from renewable energy by 2010. We missed that target. We made it only in 2013. Our 2020 target was 33%, yet we're already at 45% today. And in fact, 2 years ago, we passed a new law requiring that we become carbon neutral by 2045, as I've mentioned, but also that by 2030, we are 60% powered by renewables. In fact, we're already ahead of that target today. Across the United States, 10 different states have all set targets to be carbon neutral by mid-century. All those in green and those in blue have already established it, and all of these states in orange are considering targets that would also be consistent with this 2050 or earlier zero carbon future. That's important because as the United States re-enters the Paris Climate Agreement under President Biden, we are not starting from where we are 4 years ago. In fact, much of the country is already adopting these targets by aggressive goals for solar, as we have in California, aggressive goals for electric vehicles, aggressive standards for clean energy content. And one of the real features of that story is that the federal government now plans to invest trillions of dollars in clean energy, up to $2 trillion federally and $3 trillion from the private sector. The most important feature, in my opinion, is not the amount of money the US plans to invest, but the US is now committed to investing 40% of those funds in what we call disadvantaged, minority, underserved communities. Communities on the fence line of fossil fuel power plants, communities that have not been part of the clean energy boom of development. that investment is really the critical feature why I believe that this mixture of clean energy and justice go so well together, largely because there are so many more jobs in the clean energy space than in the fossil space. So it opens up a true range of opportunities. The more we invest in diversifying the clean energy economy, first shutting down coal, then shutting down natural gas, which is controversial still in some US states, but not in others. In fact, part of the story is that the Biden administration is now the most racially and ethnically diverse in US history. And of course, the US has already re-entered the Paris Agreement, which I mentioned before. Now, why do I highlight not just the material science of solar? I could give whole lectures around transparent solar cells or solar cells that don't require conflict materials from the Congo or other regions. The reason I say so is because to build markets and build social justice, we see a huge range of opportunities. One feature which I have highlighted in a number of my writings, including the New York Times, is the fact that in the United States, as in a number of countries, the poorer you are, the longer you must commute to good jobs in the high-tech hubs, be it in Basel or in Silicon Valley or in Texas or in London. Low-income people have to travel or commute until they qualify. An example of a policy that supports clean energy and social justice is something we recently passed with the largest ride-sharing company in the United States, which is Lyft. So Lyft and Uber are our two largest of these ride-sharing companies. Lyft has 2 million drivers worldwide. And recently, working with myself and the governor here in California, Lyft has agreed that every single one of their vehicles would be electric by 2030. It's one of the examples of taking advantage of our particularly clean electricity and finding opportunities to make those vehicles available to drivers. In the United States, many drivers of ride-sharing vehicles are first-generation immigrants, low-income individuals working in the so-called gig economy or the informal economy. So by making clean electric vehicles available to drivers, we find a way to take more advantage of renewable energy, but also to put the benefits directly into people's hands in terms of jobs and opportunities. I say that as I close because one of the pieces of science, again, my background that is so important in this process is that we're all familiar with the dramatic cost reductions of solar. This is the so-called learning curve or Moore's law that says that the cost of a new technology that we can mass produce, such as solar panels or batteries for electric vehicles, typically falls as the power law. What that means is that every time we double the volume of production, V, of solar panels, we see the cost decline by a power law. The slope of this line, it's about 0.2, 20%, meaning we see a 20% drop in the price of these technologies every time we're able to double the amount of manufacturing. That's why putting electric vehicles into operation helps to lower the cost. Investing more in energy efficiency helps to lower the cost. And these are the technological pathways that get us there. My last comment will be here in California. We established a mandate requiring that our utilities install energy storage. This is an energy storage facility in Southern California, powered by solar. This is not a lithium ion or a lead acid battery. This is a liquid flow battery, an advanced technology with many cycles. In fact, not thousands of cycles like your cell phone has, but millions of cycles before it degrades. This was installed because of a state requirement we worked on, saying that each utility must meet 2% of their demand for power with storage by 2020, a goal that the state exceeded. Now we're working on the next standard. Again, this is why I highlighted that not only getting clean technologies into people's hands, but also finding ways to use public policy and social justice, investing in low-income individuals, investing in communities that have been discriminated against, as an opportunity to build more buy-in and more social equity as we move towards this clean energy future. I'll end there, but highlight that as we think about the path we were on, warming the world by 3 degrees or more, it's only by finding these innovations that give us optimistic pathways that we can bring down our scenario. In fact, since the United States rejoined the Paris Climate Accord, China announced their goals for clean energy by 2060, South Korea and Japan announced goals for 2050, have we moved from the blue to the optimistic line. But only if we implement these technologies can we make this low carbon pathway possible. So thank you very much, and I look forward to hearing from the other speakers.
We would like to thank you too, Dan. You did it in time, actually. This was very well. Does any participant have any questions regarding his presentation? If you do have, please don't hesitate to ask the question.
Yes, I would like us to ask about the storage. About the storage, because we know that the storage has been like the issue regarding this renewable energy technology. So I just want to know a little bit more about which type of technology is using now to storage this energy, and it is about this pollution that the batteries can cause to the environment.
Yeah. So great question. So I highlighted in the talk a unconventional, a new form of storage, a liquid flow battery, to distinguish it from the lithium ion batteries in our cell phones and laptops and our electric vehicles, to highlight how much innovation we need going forward. And what Nidiana highlighted is correct. We have to be particularly concerned about the ecological and the ethical footprint of the extraction of lithium or cobalt or other materials. The fact is that these are serious, and the human rights violations in countries like the Congo are quite significant. Compared to the damages of fossil fuels, of course, they are still very small. That doesn't mean they are not a problem. That means that we need to think much more expansively about the ways that we can ensure the materials do not come from conflict regions, that we invest so that we're not supporting child labor, we're not supporting illegal mining. And one of the most interesting tools is that a number of companies, such as BMW, announced years ago that they would take back 100% of the rare earths and other materials that they use in their cars. Now, unfortunately, that doesn't mean that BMW, for example, takes back the physical atoms. They take back in the market an equivalent amount. What we need to move to in the coming years is the so-called life cycle planning, so that it's the materials that we recycle to the maximum degree possible, and we make our batteries and the advanced materials for wind turbine blades and for solar cells, that we recycle as much as we can, but we also find the least environmentally and socially impactful ways to access those. But we have to remember, while this is serious, this is still a much smaller footprint than our fossil fuel economy does, not only on the planet, but also on disadvantaged people. So great point. Thanks for saying.
Thank you, Daniel.
Okay. Anyone, any questions? Well, then I have a question down to you. Well, I heard you saying social justice and climate justice. Yeah, well, justice, that's what we all need, actually. But I'm sure what you're saying is related to environment, and we really need a green and clean environment. Can you please give more detailed definition about this word, and what do we have to do to build up this kind of justice, actually, then?
Yeah, so thanks for saying it. So I will just answer that. I will take advantage of showing a slide I skipped over for time. As an example of the social justice component, this is a project in my city, Oakland, California, which is a low-income city. This is a block which we call the Eco Block. It's a project supported by the state government of California to develop a new housing model. This is an existing neighborhood in a low-income section. In fact, one of the buildings here was previously used for drug activity. But what is agreed to on this block of 40 homes is that we're installing solar on all of these rooftops, as you see here, but it's not powering the home individually. In this case, all of the generated solar goes to a series of flywheel batteries, another advanced technology in this former garage here, that will then power all the homes and will make electric vehicle charging stations available on this block for people who own their homes, like this one here, but also for people in apartment buildings like this one here, so that we can push the benefits of clean energy not just to property owners, but to all citizens. So this is what I mean as a practical example of an investment in clean energy that is designed to promote social justice and equity, not just environmental justice. We believe that it is possible to achieve both. In fact, a stronger statement is that we believe that without social justice, ecological justice will be far more difficult, if not impossible. So that's an example of what I mean by this mixture. Let me return the screen back.
Thank you very much, Dan. Thank you very much. Really, that storage was really impressive, by the way, Jane. Now we have got the second speakers, Mr. Hasan Cangi. Do you hear us?
Yes, sir.
Okay. He's going to tell us about food and energy.
Yes, exactly.
I think to gain energy, we need to have food.
Sure.
And that's important for all of us.
Let me share my screen, please.
Yeah, okay. Please go ahead.
Mm-hmm. Yeah. Okay. Well, hello for everyone. I would like to introduce myself first. My name is Hasan Cangi. I did my master and PhD in Turkey, Gaziantep and Kahramanmaraş University. And I have my own company working as a free in energy business. So I'm going to speak regarding the food and energy. And in Turkey, there is a pilot project regarding this project by Sun Farming company. Sun Farming company is German company. And benefits of the project to public bodies, we have here two main benefits for the public bodies. One is electricity generation and the other is organic food production. So here the significant reduction in your electricity consumption is thanks to the electricity generation. We are talking about the rooftop of the PV panels on any facility building of any public body. And for the second, the income from the sale of organic food production or direct use of food. We are talking about the greenhouse. I'm going to talk about this with detail with the slides, next slides. And for the third training, the personal that who is working for this project will receive on solar energy, drip irrigation, and organic agriculture. So the project can serve in three main categories in general. One is project development, second is self-consumption, and third is the most important, food and energy. The project development by the Sun Farming establishment of large-scale PV plants. The second is establishing PV systems on the roofs of any institution for self-consumption. Small and medium-scale rooftop PV panels. The third is food and energy, serving in the fields of solar greenhouses, food production, employment, and education. Here, the food and energy, it has four important legs. One is energy production. Second is training regarding this issue. The third is employment. And the fourth is the food, which means greenhouse. The aim of this project is to present the concept of food and energy for education, sustainable job opportunities, and food safety within the scope of social responsibility principle. As it provides social benefits, such as innovative training and employment opportunities, it is one of the best projects selected Intersolar in 2017 outstanding solar projects at the largest fair of photovoltaic technologies. Food and energy benefits. Let's start from the energy production. Here, let's suppose we have a 1 megawatt PV plant in any public body. Let's suppose which is to establish this 1 megawatt in Mardin Artuklu University. The electricity production from the solar energy can be used whether for the public body, for the facility building of the campus, or can be sold to the distribution, electrical distribution company. This is the energy production. The second is food production for the greenhouse. It can be grown vegetables, fruits, and flower cultivation. The third is employment of up to 50 people per megawatt, which means for 1 megawatt can be employed up to 50 people. Fourth is education or training on PV plant and agriculture, both of them. The fourth is water management as a saving, special drip and irrigation systems. So training capacity of approximately 250 people on solar energy and organic food, 4 training programs per year. Organic vegetable production up to 125 tons. Chicken breeding, at the same time, it can be also breeding of the chicken and egg production. Clean renewable energy, prevention of carbon dioxide emissions. Here we have some projects. Here, this is in Africa. And this is the pilot project in Turkey, where is in Osmaniye province. We have here the PV panels. Under the PV panels, it's grown as a greenhouse, some vegetables under the shade of the PV panels, as you can see. Here, for the people who is employed for the project. And here, as you can see, breeding of the chicken, so it can be also produced egg production. Let me explain about the project in Osmaniye. This project established 2 years ago, close to the Syrian people. In here, they have a program for as a training and employment. For every 4 months, they are getting 50 people, which, by the way, this project is 1 megawatt, and they are hiring 50 people among the Syrian people. And first of all, they teach them, I mean, giving the training regarding the both electricity and agriculture. And then they employ them for 4 months. and every 4 months they change these people with another 50 people with the cycling every year. They make a four cycle for 200 people who they employ the people and teach them how to manage the electricity production and regarding the agriculture and so, which is really very important project for also social project. It has, as we said, 4 important legs. One is training, second is energy production, fourth is food production, and fourth is employment. And that's it. Thanks for your attention. If you have any question, please go ahead.
Okay, Dr. Hasan, thank you very much
for
the information. Does anyone have any questions about this project?
Yeah, I have.
Please, Mr. Yunus.
Please.
Yeah, thank you very much for the presentation, firstly. And you said for the energy generation, you use the solar energy, right?
Yes.
And I'm wondering, what about if you use the wind energy? I mean, for the electricity generation, and apply your project to the other part of the Turkey, where the wind potential is very high.
Well, thank you for your question. Actually, for food and energy, as you saw in my presentation, it is grown regarding the food production, grown under the shade of the PV panels. It is not applicable for the wind turbines. As you know, in the wind turbines, there is no shadow. And it can be another solution. Actually, it can maybe for both as a hybrid system, PV and wind energy all together, in order to get more and more capacity of the electricity. But as you know, also the wind turbine needs specific locations. For as technically it has been provided the sufficient wind and some technical issues, you know, regarding the wind turbines. In those locations, it could be used for both hybrid systems, for wind and solar all together.
Yeah, it makes sense. Yeah, I mean, because when I consider the efficiency of both the energy systems, I mean, the solar energy has a lower efficiency compared to wind power. I mean, depends on the location as well. But yeah, as you say, that the hybrid system could be another solution. I mean, for any specific area where the wind and also the solar is very sufficient, which could be a good idea.
Exactly.
Yeah, thank you.
You're welcome.
Okay. Thank you very much for your answer. I've got a question, Mr. Hasan.
Sure, go ahead, please.
You know, about the system that you build up in your project. I was wondering about related between the cost and revenue or outcome of it, because many people are asking for it. And also, if you include the maintenance cost, is it really worth to build up such a system?
Well, let me start for the maintenance first. The maintenance is very rarely, actually, in the maintenance, in case of failure, it is important to take an action for the failures. But for the maintenance, it has been established in Osmaniye. And Osmaniye climate is very, very good and very efficient for the PV panels because it is always raining. For the raining, the most problem for the PV panels is dust. Dust comes on the PV panel surface. So in order to clean, for the maintenance point of view, it's supposed to be clean up the surfaces of the PV panels. But because of the raining itself, it is cleaning the PV panels. That's why they located this project in Osmaniye. But if it is located in any other place, in order to get more efficient from the electricity generation, the PV panels should be cleaned up. This is the maintenance. For the other issues regarding the cost point of view, it is known almost 7 to 8 years. It has been payback period of the project. But here it has two sources of income. One is from the food and the other is from the energy. So this payback period is make the project shorter. Maybe it can get in 4 or 5 years. And at the same time, it has a good point for the social program, as I thought. In the social point of view, there is a training, and at the same time, which is the most important, is employment. Okay. And it is worthy to make an investment in this project. And from my side, I highly suggest most of the universities to make this investment, or there are another solutions to make these projects, because it will be very useful for the students at the same time. For example, students who studying on the agriculture, they can make practical in this project. At the same time, the students who study in electrical or in energy department can also make a practical, can take training, and at the same time, it can be produced the electricity, food, and lastly, employment.
They can practice it actually, yeah.
Yes, sure.
Okay. Thank you very much for detailed information.
You are welcome.
It's really worth doing that. And it will be more applicable for Black Sea part in Turkey, maybe, because it's raining a lot there.
Raining, yes, could be. It's applicable. Sure.
Okay.
By the way, I'm sorry for my webcam. I have a technical problem. I'm so sorry.
Okay, no problem. Thank you very much for the participation.
Thanks a lot.
Anyway.
Thanks a lot.
Now I've got a participant from Mexico. It's really far from us, but now I see that she will going to talk about prediction of the dynamics tool in vertical axis wind turbines. Nadiana, please go ahead. Your microphone is off. Could you please turn it on?
Yes, thank you. I will share my screen with you. Okay, so I study physics in Mexico in the University of Yucatan, and then I did my PhD degree in mechanical engineering in the Sheffield University. So I have been working in the last 8 years in the field of wind energy, and specifically trying to understand and to improve the vertical axis wind turbine performance. So I will share with you some of my research, the finding of my research in the last few years. So some of the advantage of these vertical axis wind turbines are because these turbines has a lower cost of the tower installation compared to the horizontal axis wind turbines. They have omnidirectional capabilities, so they do not need this alignment system, and they have less sensitivity to turbulence. And in the last few years, we have seen several projects around the world to try to implement this vertical axis wind turbine offshore due to this advantage, and then to try to harvest the wind offshore, because it seems that the mechanical system that they need so are easy to install compared to the horizontal axis wind turbine. So then in the last few years, there have been an increased interest around the world to investigate these aerodynamics of these wind turbines. And maybe in future, we are going to see these big farms with using this kind of technology. I hope so, So then about this vertical axis wind turbine, despite a lot of people are investigating this technology, we are still having concern about the aerodynamic itself, because there are some, the unsteady aerodynamic is very difficult to model and it's very difficult to predict. So then it is a requirement to know all the details of these aerodynamics in order to improve this power coefficient. So in general, when a vertical axis wind turbine is rotating, it's producing some aerodynamics forces, and these aerodynamics forces are able to produce the torque, and then we will have the power coefficient. So in this picture, we can see a typical power curve for a vertical axis wind turbine. So when we start at low tip speed ratio, we have low power coefficient. Then we obtain optimum power coefficient. And after that, we have a large tip speed ratio, again, very poor torque coefficient. So then, because here in my investigation, so I am focused on the dynamic stall phenomenon that occurs at low tip speed ratio, and this phenomenon has a consequence that the power coefficient is very low for these wind turbines. So my investigation is trying to guess to calculate under which condition we are observing this dynamic stall. So I will share with you some small video. Okay, so when the vertical axis wind turbine is rotating, it's creating this vortex that is called those vortex. And if you can see, this number of vortex at the end creates, at the downstream zone of the rotors, they create interaction between them. And then obviously the aerodynamics forces here decrease. Thus, the power coefficient also decrease in the performance of the vertical axis wind turbine. So the things that I am trying to do is trying to calculate in which point and under which parameters, so we are having this phenomenon, the vortex, and then trying to control this phenomenon to improve the power coefficient. So if we are able to know the governing parameters that dictate this this dynamic stall phenomenon, so then we can improve the power coefficient of the vertical axis wind turbine, and also we can use it as a control strategy during the performance of the turbine and trying to make it to stop the wind turbine or implementing some protection system. Okay, so then, so after several attempts to try to investigate these parameters, I have performing a huge amount of CFD simulations to investigate the effect of the angular velocity, Reynolds number, pitch angle, the airflow profile, and over the Stallone-Z angle. So then, for example, the Stallone-Z angle, that is the point, is the moment when the vortex start to develop. So we can see that the Stallone-Z versus the reduced frequency increase the angle as the reduced frequency is increasing. But if we compare the Stallone-Z angle versus the pitch angle, we can see that we do not have any correlation about this. And then if we compare the Stallone-Z angle versus the tip speed ratio, we also can see that there is no relation. So we cannot say that for example, there is a relation with the tip speed ratio itself. But if we do compare a new parameter that is called non-dimensional pitch rate, we can see that the Stallone-Z angle, it can be correlated with this parameter, the non-dimensional pitch rate. And this non-dimensional pitch rate then can give to us an equation, a relation, and then we can be able to do this prediction of the stall inception in the vertical axis wind turbine. So I have studied this stall onset angle and this non-dimensional pitch rate for different Reynolds numbers, and it happens the same. So it means that this non-dimensional pitch rate, it is a very good parameter to correlate the stall onset angle in the vertical axis wind turbine. And with this correlation, linear correlation, so then we can be able to predict the stall inception in any vertical axis wind turbine, as I'm going to show in the next slide. So then in the end, we observe that the non-dimensional pitch rate when the angle of attack approach to the static stall angle is the variable that defines the stall inception. So this non-dimensional pitch rate combines all the effect of the angular velocity, the tip speed ratio, the pitch angle, the incoming wind speed, and the relative velocity. It means that there is, if we want to study the dynamic stall only observing the tip speed ratio, this is not the correct way. So we need to investigate the overall picture and try to obtain a non-dimensional pitch rate value to see and to predict which is the stall onset angle where the dynamic stall will appear. So in these pictures, we can observe, for example, three different airfoils, the 20 airfoils, NACA 21, the NACA 12, the S1210. And we can observe that in this case, the NACA 21, it is presented the stall. The stall is the point when we can see the loss in the short wave force coefficient. So this point, so it is at an angle approximately of 27. For the S1210 is around 25 approximately. And for the NACA 0012, it is approximately to 15 degrees. So in this case, we can see that the thickest airfoil, the 21, is the best airfoil. It means that it can it stall a larger angle of attack, and then it can produce a larger torque coefficient at low tip speed radius. So then, okay, in the end, so after performing the simulation with the vertical axis wind turbine with the different airfoil profiles, so we can see that the thicker is the airfoil, the larger is the stall onset angle. So we can see this is the NACA 0012, that is the thinner airfoil, the NACA 15, the yellow one, and then we have the NACA 18, the 21, and this is the S12. So we can observe that dynamic stall also occurs at the downstream of the rotor, as in the video. So then we in this section of the rotor, we still need to do some further investigation to try to obtain the same correlation that I obtained in the previous slides. So then we're going to be able to predict the dynamic stall all around the vertical axis wind turbines. But in general, just having in mind that the non-dimensional pitch rate is the crucial parameter. So I have included this correlation with the dynamic stall algorithm to predict this stall onset angle. And we can see that with the new technology, the new methodology, including the prediction that I've shown in the previous slides, so we can predict the stall onset angle very similar as in the CFD simulations. So this is a theoretical value, and this is a new method that I am proposing to predict the stall onset angle. So, and with this methodology, we can save a lot of computational time when we are doing CFD simulations, and then we are able to predict the stall onset angle, changing the different parameters. So then this can help to obtain a better design in the vertical axis wind turbine. And also it can be implemented in some control systems to try to adjust the variables to delay this dynamic stall phenomenon. Okay, so then in some conclusions, so we have this, the dynamic stall onset angle is the parameter, is the critical parameters to define the performance of the vertical axis wind turbines. We need to reduce it, and we can use it to control the system. All the variables, the combined effect of the angular velocity, the pitch angle, and the incoming flow, so need to be evaluated in their effect in the non-dimensional pitch rate and the Reynolds number, that both of them are the most critical parameters to define the stall onset angle in the vertical axis wind turbines. Thank you.
We thank you too, Nidiana. It was really impressive numbers and calculation.
Do you have any questions?
Yeah, does anyone have any questions from our participants? Well, Nidiana, I've got one question. Do you have any future plans where you can apply this kind of knowledge or information in the future?
Oh, yes. In general, this vertical axis wind turbine, currently there are like 4 or 5 projects in Europe in general and in the United States to try to harvest the wind, the offshore. So there are big plans about installing these farms. And some of the issues, because these wind turbines they have some structural advantage, because you have 3 or 4 blades, and it is easier for the structural system, the mechanical system to be installed. So then the trends are towards to improve this vertical axis wind turbine performance, and then to plan to install these wind turbines offshore, but not only offshore, because in urban environments, these wind turbines are having attention for a lot of people. So then if we do not understand this physical phenomenon, obviously we cannot be able to improve the performance. So, and here the thing that I'm trying to do is trying to understand and to understand well the physics behind this, and then to improve the aerodynamic performance. Because this is it's not a new technology, but it's a technology that still requires a lot of research.
I see. Well, currently you are in touch with United States, but I think if you get in touch with other parts of the world or other scientists, you may apply in other part of the world as well, isn't it?
Yes, this is a project that is it is a project from the University of Sheffield, but now I am also collaborating with a French institution from Structure and Maritime Systems. So because they are planning to test some of these prototypes offshore.
I see.
Can I have a question?
Okay.
I have a question for Dr. Nidiana.
Okay, go ahead,
okay.
Please.
Dr. Nidiana, I would like to ask about the vertical axis of the wind turbines. Is it creating a turbulence like a horizontal one?
What do you mean, the vortex behind them, the wake?
I mean, yeah, regarding the turbulence, like for example, in the horizontal one is creating a turbulence, and it goes to the backward. It creates like a turbulence, and yeah, or
the wake.
Yes, wake. And for example,
the vertical axis wind turbine creates wakes. Yes.
I see. Okay. Okay. And what is the percentage of the vertical axis which implemented in offshore and also in the onshore? The percentage. Sorry. Okay. Let me ask you more obvious. I mean the percentage of the implementation regarding this project. Is it more applicable in the offshore
percentage, you mean, yeah.
No, oh, okay, I understand the question. So
Okay.
by this moment, the offshore, there are only some few prototypes installed offshore. There are some in Netherlands, and there is another one, I think, very close to the North Sea. Very close to the North Sea. There is a company that is called Situir that is implementing those prototypes by the moment. And onshore, it is also there are few companies working and trying to do prototypes for vertical axis wind turbine, but those are very small. So this technology is like the baby technology, because we still investigating the aerodynamics, and there is not a technology that is mature just like the horizontal axis wind turbine. So I think that we are not seeing this vertical axis wind turbine yet so frequently.
Okay, then. Thank you so much.
Thank you.
Okay, thank you again, Diana. Now our next speaker is Mr. Tanju Doğanay. He studied industrial engineering with the honor of a first-class degree from the Dartmouth University of Applied Science, and his expertise is in the field of project development, photovoltaic, and building technology. And I have more information here. He and his team recently finished a solar project in Kabul, Afghanistan, and also he has more other projects. But he is going to tell us about photovoltaic system and experiences in various countries around the world. So he has very much experience, and we are ready to listen to him. Mr. Tanju Doğanay, please go ahead. We are listening to you.
Yeah, thank you. Do you see my screen?
Not your shared screen yet. Yeah, now it's going to start, I think. Okay, great. Is that you?
Yes, it was. It was in Morocco.
Okay. Okay.
Yeah, one of the countries where I realize projects. Yeah, thank you very much. First of all, I would like to thank you for the invitation and for the organization. Today, I would like to share my practical experience in the field of photovoltaics with you, especially the different fields of application and target groups. About myself, I was born and raised in Germany. I have a diploma in industrial engineering from the Darmstadt University of Applied Science. Both my grandfathers emigrated from Anatolian Turkey to Germany in the 70s. From the early age, I grew up in the two different cultures, the Turkish and the German. You may wonder at this point how this relates to my photovoltaic projects. This is what I would like to tell you. This intercultural qualification shaped my life, and according to the focus of my work and projects. I learned to build empathy for minorities and for the socially weaker. At the same time, I feel grateful that I was able to enjoy such a great education in Germany. I could have grown up anywhere else in the world. I see it as my personal responsibility to use what I have learned for the benefit of people and the environment. And for me, photovoltaics is a technological tool to be useful for people and the environment. You will soon see this exemplified by 3 projects of mine on the next slide. I will not show any large-scale industrial projects now, even though I have more than 10 years of experience in this field. I think you know and hear about such projects relatively often. What I am interested in today is the added value of photovoltaics for different target groups. The first project I would like to show you is one in Kabul, Afghanistan. This is the orphanage called House of Hope. It is about an orphanage near Kabul in a region where there's no electricity grid. 40 orphans live in the house, 20 boys and 20 girls. They are cared for there and receive schooling. They did not have a refrigerator, a fridge or a fan for the hot summer days. The water supply was also relatively scarce. Therefore, the surrounding land could not be planted with crops and fruit trees. What I and my team and I planned a 10 kilowatt peak photovoltaic system for the orphanage. We also added a solar powered water pump, which was installed in a new well. Since 2019, the system has been converting sunlight into electricity. The electricity that isn't used in the house is stored in batteries, so that power is also available at night. The orphanage has now been lit up, and in addition to lamps, fridge, fans, computers can now be used for school education. Yes, and here you see the water supply is also ensured. The dry fallow land can now be greened, 100% by solar energy without carbon dioxide emissions, without polluting the air. At this point, mind you, about 700,000 people die every year from air pollution. 700,000 people every year. Yeah, and I think this technology is one of the renewable energy projects that I like and I love it. Next, I would like to present projects from Indonesia. Indonesia, in which I was involved shortly before the pandemic outbreak. So end of 2019 and the beginning of 2020. I was involved as a consulting expert in various photovoltaic projects on the island of Java and Lombok. Here, can you see my on my screen, my mouse? Yeah, you see. Yeah, you see here the 3 islands.
Gili Meno, which is, huh?
Yeah, Gili Air, Gili Meno, and Gili Travangan. Yeah. Next to Lombok on the left side is Bali. You see here LI, Bali, next to Bali. It's a wonderful island. Yeah, on the right picture you see here. This is I think this is Gili Meno in the middle of the 3 islands, and this is Gili Travangan. And on this top of the island, there is a 600 kilowatt peak large scale photovoltaic plant. And yeah, the system that supplies the 3 islands with electricity. Yeah, you see the islands are wonderful. It's a honeymoon island. And, yeah, 3 years ago, I was on honeymoon there, and I didn't think that I will be there 3 years later for a project. So yeah, it was a really nice meeting. Yeah.
Okay.
And the third project I would like to show you is in Germany, on a, for me, special building. On a mosque in the city of Weinheim. It's close to Heidelberg, Mannheim, south of Frankfurt. Almost 10 years ago, after many large industry projects, I realized my first installation on a social institution. The project is special for me because several perspectives come together here to form one picture. So you have to know Muslims make up about 5% of the total population in Germany. And many of them come from Turkey, who came to Germany as so-called guest workers, as immigrants. Like my grandfathers, for decades, Muslims were perceived in Germany as a working class. For me, the mosque, including the photovoltaic, is a symbol of the arrival of a minority in a society. Yeah, and a minority that is useful for people and the environment. This 20 kilowatt peak photovoltaic system produces electricity for the mosque and very important, the surrounding neighbors. Not only for the mosque, also for the surrounding neighbors. Again, completely without polluting the air. What does this mean? The mosque has become a green power plant operator. And I think this shows a good way to better understand our stewardships, our responsibilities on this earth. And with that, I would also like to conclude my presentation. The sun gives us abundant energy. According to estimates, it will last for the next 4 billion years. Let us use it for mankind and the environment for a better future. You know, in Indonesia, the climate change is in process. 2 islands, 2 UNESCO islands, are lost to the sea level rise. Yeah, and I think we have to wake up and use this great technology for the earth, for the mankind. And thank you very much.
Okay, we thank you too, Mr. Tajdo, and it was great information. And well, what impressed me actually is more related to social responsibility, because social responsibility means that business, in addition to maximizing shareholders' value, must act in a manner that benefits society. But the important things to investor is the consumer who seek investments that are not just profitable, but also contribute to the welfare of the society, actually. And these are really impressive projects. Do you have any project which you are planning to implement in Turkey?
Not at the moment, but I hope in the future.
We hope to, and it will be really great for us. Does anyone have any questions regarding his presentation?
I have one question, but
okay, go ahead, please.
Yes. So, because I have seen this in very interesting, these presentations about the photovoltaic systems and the social impact they have in these communities. So I was wondering if at some point of this experience, maybe the Dr. Tanju and Hassan, maybe they have seen something related with solar distilled waters, because those places, in Mexico, we have some cases that the water is too polluted, that they cannot drink the water. So, and we are still looking for these technologies, renewables technologies, to try to solve this issue. For example, these solar distillers and these boxes, solar boxes, to try to purify the water. So I don't know if they have seen something or have had some experience with this situation with water pollution. These using PV system maybe water.
Yes, there are some projects in Africa with these issues that we solve with solar energy, and also not only the pollution is the problem with water, also the high salt, the desolation of water is a big thing, and there are solutions, and and it's a great opportunity to use the solar energy, because even in this in these areas like Mexico or in Africa, the potential of solar energy is high, and on the other side, we have problems with the water resources, and so there are solutions, and we can implement it. That's no problem.
Thank you.
Okay, thank you again, Mr. Tajid Doğanay. But before having the next speaker, I would like to ask you, how did you get in touch with these countries? I mean, were you financed by their government, or were you partnering with NGOs from those countries, non-governmental organizations?
Yeah, it's different ways. In Indonesia, I get the scholarships of the Federal Ministry of Foreign Affairs of Germany.
Okay.
Yeah, I was an expert there for an Indonesian company, and yeah, I get a scholarship of Germany.
I see.
Germany, and yeah, in different ways. And some customers are NGOs, some customers are companies, and so on.
Okay, thank you very much again for this informative presentation.
Thank you.
We have now our last speaker, Mr. Yunus Çelik. Are you still here?
Yeah, I'm here. Yeah, I'm here.
Thank you very much. Sorry for making you waiting for us.
No worries. It's fine.
But those are, I think, all very interesting presentation, and I hear from people who are watching us. Some of them, they say we're some statistical, some number we do not understand very much, but it looks very interesting.
Yeah, my presentation is gonna be like a scientific. Yeah, it's the same thing as Nidiana did.
Okay, but they don't understand, some of them, but they still find it interesting, and they're watching us.
Yeah. I will explain slowly, and then in detail.
Okay, thank you. Yunus Çelik is going to tell us about self-starting analysis of the H-type vertical axis wind turbines. Okay.
Can you see my screen right now?
Your turn. Yeah, sure. I do see it.
Yeah, sorry, I can't make it full because I'm connected with my iPad, not from the PC. That's the reason. Sorry about it.
It looks all right. Okay, go ahead, please.
Yeah. Okay. Thank you very much. And first of all, thanks for having me here today. And let me do a quick introduction about myself. I am Yunus Çelik. I have completed my PhD at the University of Sheffield. My research project was based on the self-starting issue of the H-type vertical axis wind turbines. And today, as I said, instead of talking to the general knowledge about the vertical axis wind turbines, I am planning to discuss more scientific aspects about the vertical axis wind turbine, and also giving some advantages and disadvantages, and how can we solve it. Yeah, as a beginning, is a quick the introduction about the renewable energy. But even though the other participants have already mentioned about these problems, but I would say that as a result of human activities, such as the burning fossil fuels, the greenhouses in the atmosphere have been increasing, and which causes climate change. So for this reason, there has been an urgent need to decrease the level of the emissions by using the alternative energy technologies, such as the wind energy, solar energy, the hydrogen energy, and the biomass, etc. But among all the renewable energy sources, the wind energy has grown rapidly, and it will play an increasingly important role in the future economy. That we can employ the wind turbines in order to use the potential of the wind. But as we know that these turbines are divided into two main types, such as the horizontal axis wind turbine, which is the very often used commercially, and the vertical axis wind turbines is increasing. The attention on the vertical axis wind turbines increasing. And as we can see on the right side, and we can see the typical horizontal axis wind turbine and its the components. At the below, we can see the three different vertical axis wind turbines. So it's called the C-type and H-type and the Swedish one. C-type and H-type vertical axis wind turbines are the lift-based turbines, but on the other hand, Swedish one is the drag-based. They have their own advantages and disadvantages. But mostly, I will be talking about the H-type vertical axis wind turbine instead of the other types. But first of all, we need to understand what is the advantages and the disadvantages. Advantage and disadvantage of the vertical axis wind turbines when we compared its the counterpart version, which is the horizontal axis wind turbine. First of all, I will say that the advantages of the vertical axis wind turbine can be listed as the smaller size, quieter operation, and affordable maintenance cost. This is because all the mechanical parts and, for example, generator can be located at the ground. That makes it easy to maintain. And also omnidirectional work. This is another advantages of the vertical axis wind turbine. But sometimes it may cause some problem. It makes the aerodynamic prediction is more complex compared to horizontal axis wind turbine, because as we know that the blades of the vertical axis wind turbines rotate around the shaft and can experience the wind from any direction. That's the good thing. But after a certain the angle of attack and the blades can stall, and which reduces the efficiency. That's another drawback of the horizontal axis wind turbines. But the major drawbacks of this kind of the turbines is they are not reliably to self-start. That's the major problem. And I have been trying to solve and to understand and to solve the issue during my PhD study. That's the reason. First of all, we need to understand what is the definition of the self-starting. I can say that only if the turbine accelerates from the rest to its final operating tip speed ratio, where the turbine has already passed the plateau stage without any need of the external power. What does it mean? We can explain the meaning of this definition by looking at the figure at the right side on the top. As we can see here that there are two different characteristics of the turbine behavior. The black one indicates that the turbine with having the self-starting the behavior, and the second one, which is the red one, showing that turbine without having self-starting. Why? Because with the black line, as we can see, that turbine start from this rest, and then it is accelerating until a point, which is the tip speed ratio 1. I call it a critical tip speed ratio, because after this point, and we can understand the turbine whether will have acceleration or without acceleration. That's the important point. But in the real situation, and we can see a period of the time, the turbine acceleration is very slow, and we call that this period as a plateau stage. And then once the turbine escaped from the plateau stage to have a second acceleration, then the reach is a steady state condition, which is in this figure, which is around the 3.2 tip speed ratio. Also, it is important to note that this characteristics of the turbine behavior is only for the specific turbine. It may change depending on the different size of the vertical axis wind turbine, or the turbine with having the different the blades. It means the turbine with a black line have a self-starting the characteristics. But with the red one, as we can see that the turbine couldn't escape from the critical region, which is the tip speed ratio 1, to reach the plateau stage. But what is the reason behind this situation is, and we can have a look the figure at the below, which is the kind of like the performance of the turbine. Normally, as Nidiana said, we can have a look at the power coefficient versus tip speed ratio in order to assess the performance of the turbine. But at the same time, we can have a look at the torque coefficient as well. What does it tell us? As we can see, there is a red region, which is the critical region, and also it is called deadband. And we see that the region is below the zero, which means that this turbine have the negative torque generation at low tip speed ratio. That's the reason this turbine cannot have self-start, and it needs external power. And unless a turbine is designed to overcome the self-starting issue, which is not suitable for the urban electricity generation. That's the reason the self-starting the problem is one of the major problem to be overcome. Of course, there are several solutions people generally employed in the literature. As on the first solution could be the hybrid turbine. Hybrid turbine consists of the two different vertical axis spin turbine components. This suggests the Sudanese one, as I said at the beginning, which is based on the drag force. It is located in the inside of the configuration. Also, there is another one, which is the outer part, which is the Darius turbine, which is based on the lift force. What is the reason of utilizing the Sudanese one? I mean, the drag-based the turbine in this configuration is to increase the starting torque generation at low tip speed ratio, which assists the turbine to self-start. But at the same time, also we have to maintain the torque generation at the highest the tip speed ratios. For this purpose, the Darius turbine, which is the outer part, is used in this configuration. But even though this turbine has a good self-starting capability, but the reason of the usage or the utilization of the Swedish blades or Swedish turbine in this configuration can reduce the efficiency at high tip speed ratio regions. That's the drawbacks of this configuration. The second solution can be the blade pitching, which means that we can apply the pitching to the blades of the airfoil, blades of the turbine, in order to delay the stall. If we delay the stall, we can increase, basically, if we delay the stall, we can increase the torque generation, especially at low tip speed ratio regions. And the third solution could be a careful the selection of the optimum airfoil profile. And in this case, particularly, I'm going to discuss the J-shape airfoil profile. As you can see, that this is a bit different compared to the normal airfoil profiles. The J-shape profile, which is the airfoil, has an eliminated part. As we can see here, that we eliminated, I have eliminated a part of the airfoil at the pressure side of the airfoil. Also, we can eliminate a part of the airfoil at the suction side as well. It depends on the turbine rotation. It depends on the requirements. That's the solution. And then I'm gonna, in the next slides, I'm gonna give more the detail or more results. What is the effect of the J-shape profile on the turbine torque generation and also on the turbine dynamic startup, the process. Yeah.
Sorry, your time has run out. Could you please summarize the rest of your presentation?
Yeah, of course. Yeah.
Sorry for saying.
Okay. Sorry. Yeah, sorry about it. Yeah. Okay. Yeah, this is the result from the J-shape airfoil. But as we can see on the right side, when we apply the highest opening ratio, like a 90% opening ratio, we can increase torque generation. But at high tip speed ratios, we can significantly decrease the torque generation. That's the main drawback of this J-shape profile. And for this reason, I've proposed a novel hybrid blade design, which is to overcome the drawbacks of the J-shape profile, which is called the novel hybrid blade design, which consists of the two different parts. One is the J-shape profile, as we can see that on the top and the bottom of the blade I used. And also in the middle part, I use a normal airfoil. On the right side, the results compared with the normal airfoil and the J-shape airfoil. As we can see that at the low tip speed ratio regions, which is 0.5 and 1, we increase the efficiency compared to normal airfoil. At the high tip speed ratio, also I increase the efficiency of the turbine compared to pure J-shaped profile. That's the good thing. That's the promising results. Can be used for the small-scale vertical axis wind turbines in order to have a sufficient starting torque and also good enough the torque generation at high tip speed ratio. As a conclusion, the self-starting problem should be overcome to be suitable for the power generation. And the J-shaped airfoil seems to be a plausible solution to enhance the torque generation at low tip speed ratio. But there is a drawback of this. Airfoil is like a low torque generation at high tip speed ratio. And the novel hybrid blade is a promising design for the small-scale vertical axis wind turbine when considering at low and high tip speed ratio regions. Thank you very much. Sorry about it. I talked too much.
Okay, no problem. We thank you too. It was great information about that. I think we are close to the end of our sessions. But if you don't mind, before closing our session, I would like to ask you all just one simple question.
Yes,
I would like to know what you're thinking about this. I would like to start with Dan, if he's still there. The question is, actually, I was wondering about the future of renewable energy, because all people, specifically investors, are thinking about how worth or how logical it is to make an investment in renewable energy. So what do you think, and how do you see the future of renewable energy? Do you think it's worth to invest it right now, or do you have any other advices? Please, Dan, go ahead.
Well, it's a very broad question, I must say. So, I mean, I think you saw from Nidiana and Yunus's talk that certainly there's interesting work going on right now on smaller scale wind turbines. So this is kind of intermediate between the very small village systems that are often in the 5-10 kilowatt range. And then the largest ones being installed offshore in the world right now are actually are 13 and 15 megawatts per turbine. And so, you know, you're seeing kind of an example of the innovation landscape already across, you know, much of Europe and much of the United States. Renewables are already the least cost. Solar and wind have been identified again and again by the International Energy Agency, by many, many others, as the least cost. If you don't look at the implicit and hidden subsidies for fossil fuels, if you don't look at the physical subsidy about where the grid's been built, there's all this kind of more elaborate story. But you know, the fact that solar and wind are now the cheapest forms in many places, and that there's new innovation going on, you know, highlights for countries that have some intention to honorably meet their climate targets, you simply can't invest in any fossil fuels going forward. You can make arguments about how long you will continue to use current coal or gas or oil, but any investment going forward that's not in clean energy is simply something that you're being dishonest about. Because if you make an investment now in 2021 in a fossil fuel system, you have no intention of closing it in the next 20 years. There is just simply no investor that makes that plan. If they say it, they're lying. And so the question is really, will we be more transparent with the economics to highlight the benefits of renewables and to accelerate the transition? Because we are behind schedule greatly to do so, despite these interesting new innovations. And so I think that there's a gap between, you know, it's often called the valley of death, between when a technology looks like it's promising for a company and when it can actually take off in the market. But the technology base for solar, for wind, for storage, for geothermal, for tidal energy, they're all there. The question is, we are still biasing the system against this emerging science and technology base. So I'm not sure that's quite what you're asking, but I think that, you know, for a broad question, maybe that covers.
Yeah, but then, as I understand from you, it's not logical to invest in right now for other parts of renewable energy sources. But we all know that technology advances is very high at the moment, and most of those kind of countries are using cutting edge technology. So you still think that even those companies are not enough to get enough outcome?
Oh no, well, we're far behind schedule. I mean, as I tried to show in that slide, very few countries, arguably only 2, are actually on path, and Morocco's is an interesting one. Tanju talked about some of the projects there. Morocco is interesting because they essentially reoriented their engineering universities. Mohammed Khattanelu universities, they became centers of training in both solar and wind, but in particular in energy storage, because that was Morocco's big investment. If you go to Uluslararası and some of the biggest solar farms. So there are technologies that of course are cost effective today, but even if a solar or a wind project is least cost, it doesn't mean all the other costs will line up in their favor. We have, in California, we're now 60–70% of our average load is met with renewables, but we subsidized for quite a while. Now we don't. Okay. And now the new challenge is, can we get enough storage installed so that these renewables plus storage can fully crowd out natural gas? That's okay. The next battle here.
Thank you very much, Dan. I think it was a very honest approach to this question. Now, this next speaker, I'm coming from back to the start again. Yeah, Mr. Hasan Cengi, are you still online?
Yes, yes.
Okay, sure. Just shortly, please. Just very shortly.
Yes, sir. Regarding your question?
Yeah.
Okay, well, as Dr. Daniel said, it is the most important thing is economical. I'm going to talk about the Turkey situation now. Regarding the solar energy, so many people, so my investors, they are not willing to make an investment regarding the solar energy because as you know, for the investment, they would like to sell their electricity to the government with high cost, with high price.
Yeah.
But unfortunately, can you hear me? Sorry.
Yeah. Yeah, we do hear you. Go ahead, please.
All right. For this reason, nowadays, with the new regulation from 2021 up to 2025, they renew the price of the purchase from the government.
That's true.
The electricity prices make lower. Because of this reason, so many people are not making investment for the renewable energy. But unfortunately, it is not good aspect. Actually, would like to contribute for the social life, for the make an saving for green green energy and to reduce the carbon dioxide emissions and such this. Now the people are trying to find another solution regarding the investment. Which one is make more money? They are trying to make an investment in such those projects.
Yeah.
But unfortunately, even in the other aspect, from the government point of view, political, it's supposed to be make a good encourage the investors to make investment regarding for renewable energy, any kind of renewable energy. But unfortunately, I don't know about the political point of view. It is not good nowadays. It is not good. It is not recommending the investors or people to make investment. But it's supposed to be more and more good incentives for investors to make investments. That's it. Thank you so much.
Thank you very much, Mr. Hasan Cengi. I think the government or authority will be watching this video as well, because a report will come out at the end of the workshop, and I hope they will take this issue into consideration. I will try to find a solution for it. I also hope that the investors will take the advice from Dan and they will think and invest accordingly.
Yeah. By the way, I would like to make a small comment also. 2 years ago, I was preparing a feasibility report for Şanlıurfa OSB, the industrial zone, regarding the biomass. Biomass project. At that time, before 2021, the incentive was very high. It was about 13 cents US dollar per kilowatt for purchasing from the government side. But now it drops to the 8 cents US dollar. So in this case, nobody wants to make an investment. At that time, there were so many people, they were willing to make investment for such this project, but now, unfortunately, nobody care about it.
I see.
We wish the government take good
Exactly.
precautions for this to regulate the prices and encourage all people, all investors to make investments, especially from the abroad, overseas.
Okay. Thank you very much.
You're welcome.
Thank you very much. Now, the next speaker is Nidiana. Please, Nidiana, tell us what you're thinking about the future of the renewable energy. Please go ahead. Your microphone is off.
Yes, sorry. So I just want to add some comments, because basically if in a government, the government is the one who dictates all the policy about the energy, at least in Mexico. So if you, in Mexico, if you want to make a very large investment, obviously you need to take into account all the guidelines from the government. So, but now, for example, we are facing this issue, and I think that all over the world for the electric system resilience, that there have been several issues for the electrical system connections, because this problem in Texas and then the problem in other parts of United Kingdom because the climate change. So then I think that most of the countries are taking actions to consider seriously the renewable energy, to improve these grids, these electrical systems, to be more resilient in future, because we cannot throw in only one source of like the fuels, fossil fuels. So and we need to be prepared for that. I think that renewable energy, we are on the pathway now, so that we are still be working on that. So there is a big future in these renewable energies.
Okay, so you mean we have to keep working on it?
Yes.
Okay, thank you very much for your
Thank you.
Mr. Tanju Dona, we are listening to you. Please tell us, based on your experiences in this field.
I think I think the future of renewable energies is good, and we need a range of changes in political and economical perspective, and I think we are on track. We see in European Union there's a carbon dioxide tax for the carbon dioxide emissions. So this is one point, but I think we need more changes like that. And on the other side, we need a change in our mindset.
Exactly.
For on the one side for the investors, and on the other side, I think we need to invest in people, in the mind of the people, in education. We have to understand that we have the stewardship for the nature, for the earth, and therefore we need a spiritual connection to this earth, to this nature, and not only with books, also with practical connection. And and I think this there are more parameters what we have to consider, and I think we are on a good way, and we have to hard work on this way, and thank you.
So actually, you're right. I totally agree with you. Before investing in mechanical things, we better invest in human being with education, because then we can have a bright future for all of us.
Yeah, and maybe I would like to add to this point what you mentioned. When I started 10 years ago with the photovoltaic project on the social institutions, like the mosque that I showed you, then I realized that the people didn't understand why we do this. And for me, it was important that we first understand why we should use this technology before we implement it. And this is one pillar of my work that I sensitize and train people to get the connection, not only for the technology that they understand, also the connection to the nature. And I think that is very important. That's we have to implement it in every field of our work, in education, and also in sensitizing in companies, in governments, and also in families. Yeah, and then we can use tools and technologies like photovoltaic and wind and other good renewable energy projects.
Exactly. Thank you very much for this great idea. And I think all the countries, and specifically people who are experienced in this field, should get in contact with each other, should collaborate and cooperate with each other. And I think they will help to develop this kind of work in the future. We have last speaker, Mr. Yunus Çelik. Please go ahead and tell us what you're thinking shortly.
Yeah, okay, thank you very much. And what I believe, and there are very significant the potential for the investigation of the renewable energy sources. But I believe the governments around the world should encourage the people, not only the private sector, and also to encourage the personally people to install this kind of technologies. But at the same time, additionally, we as a scientist need to work hard to decrease the costs of the utilization of this kind of the renewable energy, the technologies. That's I believe, and hopefully in the future, and we will see more the installation or more utilization for this kind of the source, not only wind, not only the solar, also other the sources as well in the future, hopefully.
Okay, thank you so much. Thank you very much for this valuable information. Well, I think this was a very informative session, and people who are watching us I'm sure have more knowledge. And now it's late, almost late in the evening here. It's late, but not for Dan or for Nidiana in Mexico. Yeah. So as a university, and I'm speaking now on behalf of the university, I'm really glad to have you all together here in these sessions. And I'm also glad that you shared all your experiences and knowledge with all people who are watching us at the moment. And I will say thank you again for the time you have spent for us right now. And I hope next workshop, which we are also planning to do in the future, I hope that we will be face-to-face. We would like to see you in Mardin, in our university. And if you do have any questions or concerning about our university or Mardin or this kind of studies, please do not hesitate to contact us. And I want to thank you again on behalf of our university, and thank you. Okay.
Thank you very much.
Thanks so much.
Thank you. Thank you to everyone.
Thank you for everyone. Good day.